I hope I can entertain you between now and the tea or coffee break. I'm going to talk a bit about how you can link the macro world of smart cities with the micro world of people in buildings and how you actually use and maintain buildings. And there's actually a very good link between the two. There was some allusion to it in the panel discussion earlier. We are a company called MCS. We are a software and advisory company, and my clicker is not doing anything. Oh, there it is, okay. We actually, and these are some of the people that you can recognize as you walk the halls here today. We're a company focused on software technology for building management, building lifecycle management, and also advisory services to help people to either use, occupy, maintain, run buildings. We have users all over the world, in over 60 countries. Our head office is in Belgium, in Europe, and we have an office here in Dubai by the Burj. You saw Michael speaking here earlier today. He's the one on the right there. He's actually somebody who's spent a lot of time doing a PhD looking at exactly this topic of smart buildings, not just from an energy perspective, but also from an occupancy and maintenance perspective, and linking that to the broader smart grid management and energy management, and also teaches as a professor on the topic. And Adel and Ayman are local chairmen and sponsors, helping us bring our solutions to the area. And Steve and Robert, you can also recognize, who are helping develop our client relationships. So I think I need to point somewhere with this thing to actually get smart about the slides. There we go. I mentioned this, we've been in the business for 25 years, so I'll skip that. So when we say building lifecycle management, we look at all the different dimensions of lifecycle management, going from real estate. Do I have the right apartments, retail stores, office buildings, villas, etc. Doing lease management around that. We look at it from an energy perspective to say, can we take all the data from the smart meters or from the not so smart meters and actually look at all the consumption in a building, electricity, gas, water, cooling liquid, even waste, and looking at how we optimize that. We look at it from a service management perspective, facility management, maintenance, which gets into how do you optimally maintain critical installations to actually impact your energy management, for example, or the comfort in your buildings. And then all the way to space management and how people actually occupy the space. And there you can actually look for optimizations of getting more usage out of your square footage or your square meters. And we also do smart building technologies on what we call smart building, and that's essentially deploying sensors in buildings. Could be new buildings, could be existing buildings, using the Internet of Things standards, which is wireless communication over new IoT standards that can actually collect all kinds of information about the way the building is being occupied, where is your traffic, the user satisfaction, the happiness feedback that you're collecting, to the comfort, temperature, humidity, and all the energy consumption or other commodity consumption. So we deploy these kind of sensors to collect data on buildings, and that's where it gets interesting, right? So not just from can I find a meeting room, or should I go replace a filter in an air treatment unit, but more, what can I do with this data for this building or this portfolio of buildings to actually be useful in the way we manage the city or the grid at the macro level. And that's what I want to talk about today. How can you take some of the things that are happening inside a building at the level of one building or a group of buildings and actually put that in the broader perspective of the grid management. But first, let's talk a bit about trends in energy. Obviously, you've all heard about all the big trends that are going on around everything should be smart and connected. There's things about demand side management. You've heard about the objectives of reducing by 30% by 2030 the energy consumption by better investments. You've heard about being green, renewable energy sources, recuperating energy from waste, and recycling, for example, and other ways, and then also just reducing consumption, right? Can I just avoid chilling or can I, for example, reduce the amount of windows in a building on the south side so I don't have to consume as much energy? So that's just reducing energy and making your buildings greener and energy neutral. Those are trends all over the world. Everybody's absorbing these and trying to figure out how they work. And every region is looking at regulation. There's regulations coming up here as well, especially with the perspective of 2020, 2030. So how do building owners, building occupants actually deal with these regulations? How do you comply? How do you take the opportunity that's within them? And then the other one is reporting on the data. Can I report what I'm actually consuming? And can I rate my buildings? There's ISO standards, LEED, BREEAM certifications that are useful ways to detect what is the level of greenness, if you will, of the building portfolio that I have. Those are ways of making it tangible on how to absorb these trends. But what you really need to know is, what is my demand? My demand for energy, right? And when I say demand, I don't mean how much power do I need, but more, what is my occupancy of a building? A very simple example is if I walk into a meeting room, that meeting room should only be chilled when there's actually somebody showing up. It shouldn't be chilled 2 hours before, right? So how do I know when people are going to start to show up in my buildings? Same thing with a swimming pool. When are people going to start swimming in my swimming pool? So when should I make sure that that temperature is set correctly? So that's more about occupancy and usage behind the actual energy demand. Same with electrical cars. Electrical cars are coming to Dubai now too. Tesla's just arrived, and you can start seeing the charging points coming up privately and publicly. Well, what if you would know when that person's going to actually need their car, right? So actually using the car, because the car is usually plugged in 8 hours in the day, but only used 2 hours in the day. So that's what I mean by understanding your demand is becoming very important. Not just so you can manage it locally, but also you can actually interact with the grid because of that. And we'll talk about that in a minute. And that's where smart building technology is there to really capture your demand, again, at your own building or portfolio of buildings, and then actually putting that in the broader context of a smart city. Before you actually go into the advanced side of demand management or demand response management, you need to get your basics right? Minimizing the demand for energy. Like I said, can we use shading instead of cooling? Can I use less windows? Can I orient my building so it's not exposed to the sun as much? Can I use the north side to actually get the light in and the south side to get solar panels, for example? Those are the kind of things that you can do at the building construction level to minimize the demand. You can use more sustainable energy that you all know that are being built already around solar, wind, cooling networks, etc. And then when you still use fossil fuels, of course, how can you use them in the most efficient and clean way possible? By energy efficient equipment, kind of replacing that water boiler or other type things, or better maintaining them. So those are the basics, I would say. I'm not going to bore you with that too much today, but what we really want to talk about is taking that to the next level. If you say, we really want to, we talked about it earlier on the panel, balance supply and demand, but the demand growing at the macro level because of new buildings, new residents, and just things growing in general in the UAE. You really need to look for the utility providers like the DEWAs of the world are looking for ways to actually manage the peaks, not just the overall growth, but actually managing the peaks. The peaks are extremely expensive because that's very short-term, immediate supply that needs to be provided, and essentially are willing to invest in ways to actually reduce those peaks, flatten those peaks, and that's where smart buildings can actually help. So let's talk a bit about how that would work. you want to keep the balance between the production of energy, the supply of energy, traditional fossil fuels or more renewable energies that are there and growing. And even with some of the things like renewable energies are more unpredictable. You know, something like wind is oftentimes a lot harder to predict. So you have peaks and valleys in your supply, an even bigger reason to manage the peaks. And then you have the different buildings that are out there, and not just buildings, but also cars and other consumers of energy. Offices, villas, apartments, shopping malls, swimming pools, schools, hospitals, all of those are consumers of energy at different levels with different peaks, with different demand patterns. And it's really important to get a grip on, when you're running a portfolio of some of these buildings, how can I actually understand the demand for energy related to the demand for using the building? And that's where it gets interesting with some of the new technologies that are out there that can help with, can I regulate the temperature setting? Can I drive my BMS system or SCADA systems that we talked about? Can I store power, right? There's things like the Tesla Powerwall, for example, or other ways, or electric cars are ways to store power temporarily, but also flexing your demand. And that's the key point I want to make today. Is we talked about demand response management. That is really about influencing when you need that power, right? Can I delay the chiller of that swimming pool by an hour in a way that nobody in the swimming pool will notice, but I am removing a peak moment in the grid? That's a very important aspect. That's not necessarily producing energy, but it's reducing demand for energy in a very micro level. That means you need to understand the use of that particular consuming swimming pool or building, but you also need to be able to influence the chiller and actually tell it to delay its work, to retime it. So it needs technology to capture demand, and it needs technology to actually instruct the different installations to flex the demand. And when you have that in place, then you have something extremely valuable. That is something that utility providers will pay money for. Maybe not today, maybe that still needs to come in the way the regulation is set up. It's coming in Europe, in the US, and it's already becoming a very big conversation also in the GCC. There we go. So how do we do that? How do we actually make sure that on the demand side, we're not just doing reduction of energy by consuming less, but we're actually flexing the demand depending on what the grid needs, right? That's demand side level, taking it to the next stage. That's where you need smart building technology, and that technology needs to have a number of components. It needs to have, you need to have space management, to actually know when people are showing up to the office, when people are needing that meeting room, when people are swimming in that pool, when people are driving that car, when people are occupying that hospital room. Whatever your version of occupancy is to bring that into understanding that data. That's the number one thing. Number two thing is to actually understand the maintenance of your chiller, air treatment system, and other big consumers of energy, to actually understand what is their demand pattern when you normally use it, and how can I instruct it to change or delay the planning of some of that demand, and have a really tight interaction with those installations, going beyond the normal kind of, hey, you need to cool this building from 9 to 5. No, you need to be much more at the micro level on that. And then you need energy management to actually measure not just at the supply level of your whole building, but more at the installation level, put smart meters on the big critical items that are consuming that energy to really understand how demand and consumption are related. And those are some of the technologies that need to come together. That's what we call integrated real estate maintenance and energy management. That's what smart building technology at the next level is about. And once you have that in place, and I know it takes a few steps to get to that point, you can actually drive the demand on the right-hand side. You can actually say, oh, I want to delay the charging of this car. I want to change the chilling of the swimming pool. I want to only chill this, cool this meeting room when it's actually reserved, for example. That's the demand side. And on the supply side, you can actually have your flex demand as a portfolio you sell to the utility providers. And again, that's not necessarily selling just production. It's not just saying I have a solar panel that produces and I sell it back to the grid, which today is still difficult. It could just be, I am going to reduce my demand when the grid needs it. And the utility provider says, I'm hitting a peak moment, who can shut off their chiller for the next 15 minutes? And that's where you get really smart buildings helping the grid. So that's really what I wanted to present today as a concept. I know some of it is a bit futuristic, but a lot of the real estate owners or occupants are starting to set up the technology to be ready when that hits the market. I just want to show one more slide to wrap it up. How do you actually get started? Let's say you have 300 buildings with apartments, residential area, or you have shopping malls, or you have a school group that you need to manage. How do we even get started into making my building smart so I'm ready to do this? The first thing you do is track your occupancy. That can be with new wireless technology. The IoT sensors exist today to track how people use the space, classrooms, hospital rooms, meeting rooms, traffic. Those are easy to deploy even in old buildings. Even if your building is 20 years old, you can actually deploy these sensors without any cabling, which is the way you can model and capture your demand. The second thing is set up your demand flexing. Right? So once you know this demand, can I now tell my air treatment system what to do? Can I set up an integration with my BMS system to actually control the way my demand pattern is? Right? To either reduce it for yourself or to be able later on to sell it to the grid. The other one is setting up energy management software, a platform at your level, not the smart city level or the international level, but the level of your portfolio of buildings to say, where are my bad performers? Can I benchmark all my schools? Can I see which school I should go look into to actually reduce the demand there or flex the demand there? And be able to get a control over the portfolio that you have. And then last but not least is actually set up that commercial process with utility providers, with the grid, to actually take that demand and the flexibility that you have to control it and actually value that in financial terms. So it's not just about reducing your own energy, it's also about giving something, information and control that is very valuable for the people who are providing to the grid. So that's my main point that I wanted to make today. As MCS, we really believe in the conversion of real estate, occupancy and energy management, and having smart buildings be at the center of the way the grid will be managed in the future, and helping people to actually start taking those steps in that direction already. Thank you very much.